In this video, we are just going to practice separating differential equations to make sure we have those algebraic steps correct. And we're just going to do various ones on this worksheet, and then you can finish those up. So I'm trying to do one of each type, so then you'll have one to practice. So let's start with number one. Number one, you can see that in this one, we need to get the y's with the dy and the x's with the dx. So if I first multiply both sides by dx, because we have to remember we have to use algebra properties, so that works. I still have that y that I want to divide by. Now this is something that I've been stating a number of times. If there is a scalar of any sort, take it away from what you're solving for. So in other words, I do not want it with the y's because I'm trying to solve for y. Okay, and that's all we're going to do. Because now the y's are with the dy and the x's are with the dx as well as the scalar. Okay, let's try the second one. Now the second one, what I want to point out to you is if you multiplied both sides by dx right now, you're going, so don't write this down, you are going to notice that there is going to be no way algebraically how we're going to be able to separate this. The only way that we can separate it is to recollect that dx and divide both sides by negative 4y plus 5. So that's basically a quantity. So in order for us to integrate, that's what we have to do there. And those are the ones they typically put, of course, on the free response, which trick us a little bit because sometimes that can be difficult. Okay, let's drop down to the third one. Now, I want you to see ones that work as well as ones that don't work with our knowledge of differential equations. So think about this one. Just like I mentioned in the second one, if I multiplied everything by dx, both sides, this one, it is going to be impossible to collect the x's with the dx and the y's with the dy. So they call this one a non-separable differential equation, so we can't solve it. Okay, so I want you to see one that doesn't work. Okay, let's slide over to number 10. Think about what we would do in number 10 and hopefully you multiply both sides by dx, and that's about it, the best we can do. Then we would be ready to integrate. Okay, the next one is 13. Think about on that one how we can get the x's with the dx and the y's with the dy. Hopefully you're thinking factor. Factor out that x, multiply both sides by dx, and then we can divide by that entire quantity of 1 minus y squared. Oh, and in their answers, when you go to check this, I'm just looking at their answers, that for whatever reason they changed this to a plus, so then they have a plus here. But our problem had a minus, so we're just going to stick with that right answer. Okay, two more. So number 18, think about that one for a minute. This is the one that as I did this worksheet, the one that I had to think just a little longer on. I just had to remind myself that when we are, an L must just be a scalar of some sort, so we'll just assume that that is a scalar. But on this one, I wanted all the p's. So at first I thought maybe I should distribute, which I could have, and then divided by LP minus P squared, but I just had to make sure I got both of those factors to the other side. Okay, last one, number 21. Now we saw this before on page 29 in your packet, where you can separate these, but you separate by multiplying, because e to the y times e to the negative 3x. If you combine them back together, you'd have to add those exponents to get y plus negative 3x. And then they switch this on us, so the dx is on the top. So I want to take the x's to the left, and I can just write that as e to the 3x. I'm going to multiply both sides by dy, and you could do this in several steps, or in one, and I'd get e to the y dy. Just want to be